Right, in this video we will do problem number 3 from quiz 2 of last year. First, we recognize that it is a sum of forces equals MA exercise. So we must do a body diagram for each object. Object A has a normal force up, it weighs straight down, the tension is pulling it to the right, and friction is opposing the movement, it's going to the left. For object B, I have the normal force going straight up. I have a force of 750 newtons going to the northeast. The tension pulls it to the left. Friction opposes the movement to the left, and the weight straight down. So for each body, we have to do sum of forces in the x and sum of forces in the y. For A, we know that the sum of forces in the y is 0. It's not jumping or going through the floor. So the normal force minus the weight must be equal to 0. So the normal force has the same magnitude as the weight. For the sum of forces in the x, we know the acceleration in the x is not 0. And we have to remember that both masses should have the same acceleration. So instead of calling AA or AB, we're just going to call it AX. So the tension minus the magnitude of the frictional force is going to be equal to the mass times acceleration. We know that normal force has the same magnitude as MAG for body A, so we can just solve for T. We're going to call this equation 1 because we'll need it later. For body B, same thing, sum of force in the y has to be 0. So the y component of the force is F sine theta plus the normal force minus MBG must be equal to 0. So the normal force here will not be equal exactly to the weight, since you have this other force with a component in the y. We'll call this equation 2. Then we do the sum of forces in the x, should be equal to MB times AX. The x component of that force is F cosine of the angle minus the tension to the left minus the friction to the left. This should be equal to MB times acceleration. And we call this equation 3. We'll rewrite equation 3. And then we'll substitute for the tension and the normal force of B, the expressions we found before. So write down what we had from tension from equation 1. And then we'll write down what we had for the normal force B from equation 2. So this problem is not so much conceptually difficult as it is just algebra difficult. There's a lot of expressions to keep track of. So then you just solve for the acceleration in dx from that long equation we just wrote down. It's worth mentioning that you could have solved this problem a little bit quicker if you don't recognize that mass A and B could be treated as an isolated system with an external force F, a combined mass of MA plus MB, and where the other external force was the friction on the two bodies. But in this exercise, they wanted you to do the sum of forces in the x and the sum of forces in the y for each body. Once you find the acceleration, you can plug in the numerical value to AX or the expression for T, and then get the tension, which in this case would have been 203 newtons. So to review, first you recognize it's a sum of forces equals MA problem. Do a body diagram for A, a body diagram for B. Set up sum of forces in the Y for A, sum of forces in the X for A. And you get expressions for the normal force and the tension. Sum of forces in the Y for B and in the X. It helps to label your equations, and then you have to do a bunch of very annoying algebra. All right, I hope that was useful.